So today we're going to take a look at another day of the unit circle. So we can call this one Unit Circle Day 2. So a couple reminders from yesterday, those special right triangle values. When our hypotenuse is 1, opposite 30 degrees, the ratio is half. Opposite 45 degrees, the ratio is root 2 over 2. And opposite 60 degrees, the ratio is root 3 over 2. And so what we did yesterday is we started looking at all these different unit circle values, these common values. So for example, yesterday we said, let's say find the sine of 120 degrees. So the first thing we did is we put our angle in our quadrant. So 120 is over here. We drew it straight down to the x-axis to make a right triangle. And then we said, okay, if this is 180, so our reference angle, make this a little bit bigger, right in here has to be 60 degrees. Hypotenuse is 1. Opposite 60 we know is root 3 over 2. So this would have to be 30 up there in that triangle. Opposite 30 is 1/2. And then to get to that end point of the angle, we go backwards and up. So -1/2 there. In sine, opposite, and we always go opposite our reference angle. So root 3 over 2 divided by 1 equals root 3 over 2. So let's try one more of these. So the second one. Let's say we have the cosine of 300. So 300 would be in this quadrant. Again, we go straight up to the x-axis. So that's 300, 360. So our reference angle in here, 300 to 360 has to be 60. Our hypotenuse is 1. Opposite 60, root 3 over 2. So this side has to be half. We go over and down. So that one has to be negative. Cosine adjacent over hypotenuse and would be half. So we did a lot of sine and cosines, but I want us to be aware we can do tangents as well. So for example, let's say I said the tangent of 240 degrees. So tangents, 240 is down here. So we have 180 to 240. So our reference angle is 60, opposite 60, root 3 over 2. So this would have to be half. We go backwards and down, negative and negative. Tangent is opposite over adjacent. So negative root 3 over 2 divided by -1/2. Well, since our denominators would reduce out, since they are the same, so we have negative root 3 over -1, which would just be negative root 3. So let's take a look at one more tangent here. So let's say we have the tangent of 150 degrees. So our tangent, so 150. Well, I know 150 to 180 is 30. So opposite 30 is half. Root 3 over 2, so that would be negative because we're going backwards and up. So we have opposite over adjacent. So our 2's would reduce down, 1 over negative root 3. And then we're going to rationalize this. We're not going to have a root symbol in the denominator. So we rationalize by multiplying by the number 1, just disguised as root 3 over 3. So this becomes root 3 over root 3 times root 3 is 3. So -3. And then let's not forget, I just realized I did an awful lot of 30, 60, 90 ones. What if I said the sine of 225 degrees? So 225 is down here and 180. So that means our reference angle has to be 45. So this is root 2 over 2, root 2 over 2. We go backwards and down, so negative and negative. Opposite, so negative root 2 over 2 over 1 is just negative root 2 over 2. So as you guys can see, these values really start to repeat themselves a lot. But now what we got to do is we have to figure out what happens if I have something that's like the sine of 90 degrees. Well, the sine of 90 is right up here. And we said yesterday it's a unit circle, so that's the coordinate 0, 1. And what is our sine? Well, let's take a look and summarize all these here. So if I was to draw all 4 quadrants here, and I was to put triangles in all of them, it's going to look like a lovely little bow tie here. If I was to label these, this is our x value, our y, that would be a negative y, this would be backwards x, positive y, and negative y. Our reference angle is always at the center. Hypotenuse is always 1. So what is our sine value? If I said the sine of theta, opposite over hypotenuse, y over 1, it's always our y value. Sometimes it's going to be negative, but it's always our y value. The cosine, adjacent over hypotenuse, x over 1, is always just our x value. I just realized it stopped recording, and I'm not sure where. So again, just kind of to summarize, we made all these triangles, and so we said in all of them our sine is our y value, our cosine is our x value because it's adjacent over hypotenuse, and tangent is y over x. So if we were to look at 90 degrees, the sine would just be our y value. So if I said find the cosine of 180 degrees, right here is 180, so that's the coordinate negative 1, 0. We know cosine is our x, so it's just negative 1. And if I was to say find the tangent of 270 degrees, we could go 270, 0, negative 1 is our coordinate. So y over x, negative 1 over 0. Well, we can't divide by 0, so we'd say that that is undefined. And let's not forget, we could always go counterclockwise on all of these. So for example, if I said find the cosine of negative 120 degrees, let's see, negative 90 would be down here, so negative 120 would be this way. We still go exactly to the x-axis. So, and if we don't like that, what could we do? We could just add 360 to find the same spot if we don't like negatives. So that's really 240 degrees, which would make this a 60-degree reference angle. So we'd have negative root 3 over 2 because it's going down, negative half. Cosine is our x value, so it would be negative half.